In this video, I want to take some time to review some beginning probability stuff as well as some simulation. In here, I wanted to just basically do some examples. So simulation, 57% of Americans are willing to pay for a product that is made in the USA, so willing to pay more. How would you simulate a random sample of 20 on the calculator? All right, so one way to do it would be using your calculator, doing RandInt. I chose to do RandInt 1 to 100 since it was a percentage, and I picked 20 numbers. And you can see here, I would get my 20 numbers, and you would just designate. You would say any number between 1 and 57 is classified a yes. They would pay. 58 to 100 is a no. For the random digit table, if you recall, this is when you would go to this big long table of random digits. I would assign, in this case, a little bit differently. I would assign, instead of 1 to 100 like with the calculator, 0 to 99. So then 0 to 56 would be yes. That way, you don't have to look at 3-digit numbers and throw out a ton of them. You just look at all 2-digit numbers and just pick as you go along. It's not important here to have distinct numbers. You know, if 33 is picked twice, that just represents 2 yeses. Conditional probabilities. This is a formula that is provided to you on the AP exam, and just make sure you remember how to use it. This is the probability of A given B. So the probability of A occurring given that B has occurred. So it's really a reset of our sample space, saying if we know B happened, what was the likelihood of A? And the formula is the probability of A and B divided by the probability of B. So again, kind of resetting that sample space. So I just wrote a couple of examples. I'm sorry the writing is small here, but what is the probability that a person has a pet given that they are a male? I would always recommend going back to that formula and saying, okay, the probability of a pet given they are a male is equal to the probability of pet and male divided by the probability of male. And then we can use our chart, whatever thing we have to get the answer. So the probability that they have a pet and are male, a male with a pet, is 0.41, so that will go in the numerator. And then divided by the probability that they are a male. So male, we go along, 0.49 of this group was a male, so 0.49. So divide that, and that will give you your final answer. Next, and I'll read this because it is small. It says, in a group of 100 sports car buyers, 40 bought alarm systems, 30 purchased bucket seats, and 20 purchased an alarm system and bucket seats. Let's start by just making that Venn diagram then. We have 20 people, we've got alarm system, we've got bucket seats. We have 20 people that purchased both. Now it said 40 bought alarm systems, so apparently 20 bought the alarm alone for a total of 40 people. And it said 30 people bought bucket seats, so apparently 10 bought bucket seats alone for a total of 30. If a car buyer chosen at random bought an alarm system, what's the probability they also bought bucket seats? So again, going back to my formula, this is the probability that they bought bucket seats given they had bought an alarm system. So let's write this out. Probability of bucket and alarm system divided by the probability of alarm system. Now just remember that our total number of people was 100. Okay, so the probability of both, well, that was the 20 people out of the total 100, so that probability is 0.2. And the probability of the alarm system alone, that was 40 people out of the 100, that's 0.4. So again, I would just always kind of go back to the formula, and it is provided to you. Read the problems carefully, and I always like to just write down, in context what has happened, so then I can just fill in the numbers very easily. Tree diagram problems. An insurance company sells home insurance policies. 50% are sold for single family, 35% for townhomes, the rest for condominiums. Of these policies, in a given year, 12% of single family homeowners will make a claim, 9% of townhome, 5% of condos. Given a claim has been made, find the probability it was made by a townhome owner. So let's make a tree diagram about this. And you always look in trees for how things, if things are being divided. You know, we're dividing into categories. So single family, townhome, and condo. Claim, and of course then not a claim. And I always like to write, probability of single family and claim, probability of single family, it's the right letter here, and I'm going to write claim with a little c. Remember, that means complement, means not a claim. Townhome, 9%, so 0.09, and therefore 0.91. So probability of townhome and claim, probability of townhome and no claim. Finally, condo, we got 5%, so 0.95 goes here. So probability of condo and claim, probability of condo and no claim. And of course, I would like to calculate these values. The way you do that is simply by multiplying. 0.5 times 0.12, like that. Let me do that and fill those numbers in. Okay, I've filled those values in. Some things to remember about the tree. They represent the whole sample space, so these values in red must add up to 1, and each of these two values will add up to like 0.5, these two will add up to, and so on. All right, given a claim has been made, find the probability the claim was made by a townhome owner. So again, let's use our conditional formula. Find the probability of townhome given claim. So probability of townhome and claim, use the right notation here, and claim over the probability of claim. So townhome and claim was right here. So 0.0315 goes on top. Now the probability of claim is all of these three claim ones added together. And that value is 0.099. So that calculation will then give you the probability of that conditional, that it was a townhome given they've made a claim. Independence. Independence, remember, in actual life means the probabilities don't affect one another. The way we can calculate is by simply multiplying independent events. The other thing that this gives us is that if you'll recall, the probability of A or B is always the probability of A plus B minus the probability of A and B. And the reason we have to do that is because there might be an overlap, and if we add probabilities, we might accidentally add something twice. But we can replace in independent events this probability of A and B with the multiplication. So we get to have this new formula for independent events where it's probability of A plus probability of B minus their product. So that's kind of a nice thing to happen. Finally, what does it mean to be mutually exclusive or disjoint? The best way to remember it is this Venn diagram. Okay, event A, event B. They have nothing in common. It is impossible to be in both circles at the same time. Okay, so mutually exclusive means the two events cannot occur at the same time. This, of course, gives us the ability to simply add probabilities together. To find the probability of A or B, we'd simply add these two because there is no intersection.